Hi everyone, let's go ahead and do our pre-lab questions for experiment. I don't have a number for that experiment, maybe experiment 5. So that is going to be solubility, okay, KSP. So the question 1 and 2, you guys can do that. Okay, let's look at question 3. Question 3 through 7 refer to the following situation. 0.492 grams of solid calcium chloride transferred to a small beaker that contains 10 milliliters of 0.2994 molar sodium hydroxide solution. So what is it saying? Let's say you have a beaker. In this beaker, you already have 10 milliliters sodium hydroxide in a beaker. Okay, and then the concentration of that sodium hydroxide is 0.2994 molar. And to this, you are adding 0.492 grams calcium chloride. Okay. Okay, so now you have sodium hydroxide and calcium chloride together. After swirling the flask to mix well, the mixture is allowed to sit for 5 minutes, and then the solid precipitate is separated from the liquid solution via vacuum filtration. So what is happening when you add sodium hydroxide and calcium chloride? Sodium hydroxide plus calcium chloride. What's going to form? It is going to form sodium chloride and calcium hydroxide. Sodium chloride is soluble in water, and then the white precipitate that it talks about here, it's saying it forms a precipitate, a solid, and that is going to be your calcium hydroxide solid. That's the white solid. Okay, in this experiment and all these calculations, we're going to find out in two methods what is the KSP. KSP stands for solubility product. Okay, KSP. Solubility product, KSP. We're going to find out what is the KSP value for calcium hydroxide. Okay, so first we mix these two ingredients, sodium hydroxide and calcium chloride, and form calcium hydroxide. And then once you form it, you let it swirl and also let it wait for 5 minutes. Now this is being formed, and there will be some hydroxide in the solution as well. So this is your white solid, but there are some hydroxide ions in the solution as well over here. Okay, and then you check the pH by dipping the pH meter. So the pH happened to be 11.70, which is a higher pH, right? Higher pH because now it is basic. We have sodium calcium hydroxide in the mixture. Now there are several questions that you need to answer, and they are all stepwise. Let's look at the first question that we need to answer. The first one is asking, easy one. How many moles of calcium ions were added to the beaker? How do you find out the number of moles? How much calcium chloride has been added? It's 0.492 grams. 0.492 grams. We want to find out the moles. How do you find out moles from grams? You guys know that. You learned when you were little, right? When you were taking Chem 1, now you're big girls and boys. So we have 0.492 grams. You can calculate the number of moles using the molar mass, which is 110.98 grams per mole, 1 mole. Okay, so 0.492 over 110.98, that will give you the number of moles. Can you calculate the number of moles and tell me what the number you got? I have to do everything for you guys, huh? So, see, you get something like this. You have to keep the answer in 3-6 fix. Something like this. I'm going to write it down since we need this information for the next one. 0.00443. I may be wrong, so please check the answers, okay? If you get it wrong, don't blame me, okay? Okay, so that's the number of moles. Question 4. Calculate the initial calcium concentration for the mixture described in question 3. Now we found the number of moles. How do you find out the concentration? What do you need to do? Molarity is moles over volume. So you take this number of moles, 0.00443 moles. What are you going to do? You have to divide it by the volume. What is the volume that we have? Which volume is it in? It's in 10 milliliters. So you have to divide it by 10 milliliters, but we need to convert it to liters. So 10 into 10 to the negative 3 liters. When you do that, you will find out the concentration or molarity of the initial concentration of calcium ions. And that would be 0.443. 443, not 444. 443. Okay, in 3 sig figs. And that is the initial concentration of calcium ions. Next one. Use the measured pH of the filtrate 11.70 to calculate the equilibrium hydroxide concentration in the solution. Now we are given the pH. We want to find out the hydroxide concentration. How do you do that? Remember, pH plus pOH equals 14. So then the pOH would be 14 minus 11.70. That is going to be 2.30. That's the pOH. So then the hydroxide ion concentration would be 10 base negative 2.30. Okay, do this calculation in your calculator and see if you're going to get a number like this, 0.0050, and that is going to be the equilibrium hydroxide concentration. Okay, so far we know the initial concentration of calcium, equilibrium concentration of hydroxide. Our goal is to find out the KSP by constructing an ICE table, ICE table. Okay, use your answers to question 4 and 5. Question 4 we have initial concentration, 5 we have equilibrium concentration of hydroxide. Use your answers to questions 4 and 5 to set up an ICE table so that you can calculate the equilibrium concentration of calcium ion. Now we are trying to find out what is the equilibrium concentration of calcium ions. Okay, you calculate the initial concentration of calcium ions in question 3. No, question 4. You calculated the initial concentration of calcium ion in question 4. This is a typo. This should be 4. Okay, because question 3 is the number of moles, but it is going to be 4. Question 4. Excuse me. The initial concentration is the concentration of the sodium hydroxide solution used in 2.994. That's the initial concentration of sodium hydroxide. And then we calculate the equilibrium hydroxide concentration in question 5. Right? Question 5, which is 0.005. Refer to the report sheet how the ICE table for the dissociation of calcium hydroxide should look. Since you know initial hydroxide and equilibrium hydroxide, you can calculate the change in the hydroxide concentration. Let me see. KSP. I'm looking something. Calcium hydroxide handout. Just to give you how it is given here. Calcium hydroxide. Okay. So for the ICE table, let's use this one. I will post the handout for the calcium hydroxide. I don't think I have posted it yet. So we can write the ice table like this. So initially this calcium hydroxide is already been made. So we have calcium hydroxide. It's a solid. So it's dissociate to give you calcium ions and hydroxide ions. Okay, and then for the calcium hydroxide, since it's a solid, we don't need to use the values for these. But we know the initial concentration of calcium ions. Remember, we calculated in question number 4, that is going to be 0.443. And the initial concentration of hydroxide ions were given to us, which is 0.2994. Okay, and then we also know the equilibrium concentration of hydroxide ions in question 5, which is 0.0050. Now, since we know the initial concentration for hydroxide and the equilibrium concentration, we can find out the change by subtracting between these two. 0.2994 minus 0.05 will give us 0.005. I'm missing a 0. 0.005 will give us the change of hydroxide ion concentration. Okay, that would be 0.2994 minus 0.005. That would be 0.2944. How we get is between initial and the equilibrium concentrations of hydroxide. Now you can see that due to the stoichiometry, 1 mole of calcium ion react with 2 moles of hydroxide. Since we found out the change of hydroxide is 0.2944, you have to divide that by 2 to get the calcium ion concentration change. Okay, so 0.2944 you divide by 2, that would be 0.1472. So this number came by dividing this number by 2. Okay, and how do you find out the equilibrium concentration of calcium? You subtract 0.443 minus 0.1472. Since we have 3 decimal places, you have to keep the answer in 3. There would be 0.296. Excuse me. Now you found equilibrium concentration of calcium ions and equilibrium concentration of hydroxide ions. Okay. Now the question is asking, calculate the equilibrium concentration of calcium hydroxide. So the equilibrium concentration of calcium hydroxide is going to be 0.296. Okay. Now the next question, use your answers to 5 and 6 to calculate the numerical value for Ksp for calcium hydroxide. Now the Ksp for calcium hydroxide would be calcium ion concentration times the hydroxide concentration raised to the power 2. So calcium 0.296 and hydroxide 0.0050 raised to the power 2, and you will do this calculation to find out the Ksp value. Okay, and you can keep the answer in 2 significant figures. Okay, so I will leave it up to you guys to find out that answer. Now the question 8. Solid calcium hydroxide. So to answer the question 8 through 10, consider the following situation. Solid calcium hydroxide is added to 50 milliliters of deionized water. Remember the calcium hydroxide you made in the previous calculations. So that calcium hydroxide, remember you vacuum filtered it. Your actual experiment is also going to be similar to this, and your calculations also going to be similar to this. Okay, so you should be able to do those post lab calculations without bugging me. Okay, Let's see how it's going to happen. Now see, let's say you take that calcium hydroxide after vacuum filtered, you put it into a beaker, and then you add 50 milliliters of water, deionized water, and then you're gonna stir it. So when you stir it, what's gonna happen, this calcium hydroxide here, it's a solid. Now you add it to the water. Now it is going to dissociate into calcium ions and hydroxide ions. Some solid will still remain, but the calcium hydroxide will goes to the solution after you mix it. Okay, after the stirring period, undissolved solid remain at the bottom of the solution. So not all the solid is going to be soluble. That's what we want. We don't want all the calcium hydroxide to be soluble, so then it will not be a saturated solution. We want to have a saturated solution. So the solid calcium hydroxide is in equilibrium with calcium ions and hydroxide ions. Okay? And then the pH of this saturated solution was measured and it became 12.40. From the pH, calculate the equilibrium hydroxide concentration in the saturated solution. pH is 12.40, so then you know pOH is going to be 14 minus 12.40, which is 1.6, and then you can find out hydroxide ion concentration, log base 10 to the power negative 1.6. Okay, that would be, you can also do your calculation to make sure that I do my calculations correct, 0.025. So that's the equilibrium concentration of hydroxide ions. Okay, and you will see your actual post-lab calculations also very much similar to these type of calculations. So see if you can do those calculations yourself. And then the question 9, use your answer to question 8 to set up an ice table so that you can calculate the equilibrium concentration of calcium ions. So again, we can do calcium hydroxide saturated solution, calcium ions and hydroxide ions. Ice table. So this, it's a solid, don't worry about that. And then the hydroxide, we know the equilibrium concentration 0.025. Now it's asking equilibrium concentration of calcium ion. So the molar ratio is 1 to 2. If the equilibrium concentration of hydroxide ions are 0.025, so the calcium would be, when you divide it by 2, that would be 0.013. Okay, equilibrium concentration. Use your answer to question 8 and 9 to calculate the numerical value of Ksp. EC, right? So you know the calcium ion concentration, you know the hydroxide 0.025, so you can calculate the Ksp. That would be 0.013, 0.025 hydroxide raised to the power 2 and get the answer. Okay, and keep it into sig fix. That's all. All right then, bye for now.